All right, matrix equations. Um, Matrix equation is just another way of writing a system of linear equations. We've seen before that a system of linear equations can be written either as a system like this or as an augmented matrix. But you can also write it out as AX equals B, where this is A, this is X, and this is B. Now, here's why. If you take this A matrix, I'm going to copy it down here, 2, 4, 3, 5, -1, -1, -2, 3, 0. If you take that and you multiply it by x, y, z, notice this is a 3 by 3, and then this is a 3 by 1, 3 rows, 1 column. If you multiply this out, what you get when you do the top times this column, you get 2x plus 4y plus 3z. And when you do the next row, you get 5x minus y minus z. And the last row gives you minus 2x plus 3y plus 0z. So it gives you that, which is the coefficient or the variable side of your system. So if you have that equal to 491, that's really the same thing as the system that has this equals 4, this equation, or this equals 9, and this equals 1. So that's part of the reason why matrix multiplication is defined the way it is, so that we can write this out as a matrix equation or as a system or as an augmented matrix. Let's look at this example down here. Solve the matrix equation given here. Now, the way I would solve this, actually, let's talk about it a little bit, and then I'll show you what I would actually do to solve this problem. If you take this and you multiply it out, this right here times this would give you 4x plus y. I'm going to be all formal here. 4x plus y, then 2x minus 5y equals 10, -4. So we could write it out like that, and then that would give us 4x plus y equals 10, and 2x minus 5y equals -4. So that's the system we want to solve. Now, I wrote all that out because this is the first example. But truthfully, if somebody told me, solve this matrix equation, all I'm going to do is I'm going to translate it into the augmented matrix. I'm going to row reduce it. And while I could do this one by hand, octave is just so much quicker. I'll put that in here. Let's see, what do we have? Oops, I switched off there. Octave, let's see, we've got 4, 1, 10, 2, -5, -4. We'll reduce this thing, and I get this. 1, 0, 23 over 11, 0, 1, 18 over 11. So my solution is x is 23 over 11, y is 18 over 11. All right, so this next one, if we do this with octave, we can do it really fast. Let's see, solve this matrix equation. I'm going to rewrite that as 1, 1, 4, 6, 3, 2, 1, 7, 5, 5, 9, 19. Call it n just to be different this time. 1, 1, 4, 6, 3, 2, 1, 7, 55919. We'll reduce it, and let's see, we get 201. That's not what I was expecting this to give us. Let me double check my matrix, make sure I put it in correctly. 135, 125, 419, 6719. Yep. So that was correct. Gives me 201. So that gives me x is 2, y is 0, z is 1.